Hey everyone. Guess where am I? Where do you think I am? Yes, everyone. I'm in Bangalore. This is Vedantu office. Yes. For advanced result party. Hopefully, yes. No khichdi today. No khichdi today. Yes, I am in Vedantu's office right now, everyone. Am I audible, everyone? Wednesday को छुट्टी क्यों है भाई? Wednesday को result नहीं है. Result is on 15th. So there's no छुट्टी. Thank you so much, everyone. Thank you so much. I'll be traveling back next Monday. So this week you will be seeing me with this background or some other background also. Cool. Thank you so much for the wishes, everyone. Cool. Very good. Awesome. Quickly now say hello to your class teachers. बाद में end में बात करेंगे बहुत सारी. Okay. Shimon sir brought iPhones 13 Pro Max. Okay, so all these non-academic questions you know when to ask. We'll be speaking about all these things towards the end of the session. Yes, this is better. This is much better. Okay. Cool. Awesome. Everyone. Yes, birthday party है मेरे यहाँ पे. Everyone, say hello to your class teachers quickly. We have Anshul sir, Anil sir, and Rishabh sir as your class teacher. Quickly say hello to them. Hi, class teachers. Welcome to the class. All of you, quickly say hello to your class teachers. Yes. Everyone is ready for session number 3 of fluid mechanics. Okay. So, आज unknowingly, non-deliberately, there is a good news that session has, I think, the least number of slides today. There are only 46 slides that we have to cover today. 10 तो बहुत ज़्यादा कम हो जाएगा. So we have around 46 slides. So let's try to finish it up. Then we can speak. Right, everyone? Yes, for those who are wondering what exactly is the background, this is one of the pods in Vedantu's office. I'm in Bangalore. I'm in Vedantu's office right now. There is J Advanced Results expected. Already there is a buzz. You guys also start telling everyone that this time Vedantu is going to rock the results. Okay, so Vedans are going to rock. Yes. We'll see, Aditya, we'll see. Everyone's ready? Shall we start? Everyone's ready? Plus one in the chat box quickly. Everybody in the chat box. Thank you. Okay, so as always, switching off the chat so that we focus on the screen. Okay, yeah, we'll see, Aditya, if we'll be able to finish early or not. Vishal and everyone. Okay, yes. So everyone switching off the chat so that we all focus on the screen here. So always we start with a quick recap of what we did last time. So today also we'll be starting off with that recap only. So last time we spoke about how the pressure is dependent upon different types of accelerations which might be given to the fluid. We realized one thing, that whenever a fluid surface is spoken about, so if there is some fluid in any container, if there is a fluid in any container right now, you can see that this bottle, even if it is tilted, you're able to see that the water layer is still being at the horizontal. Means the free surface is still trying to maintain the horizontal level, right? That simply means that the only force which is acting is the gravitational force. So the free surface always aligns itself perpendicular to the direction of the acceleration. So if this is how the free surface is arranged, this is only because of the g value being vertically downward. But then we talked about the situation that what if you take this container and you start accelerating it continuously accelerating in a given direction. Okay, but obviously fluid remaining stationary with respect to the container. So in that case, if this is the container, okay, in which you can say the container is being accelerated in this direction with an acceleration a, we did a very lengthy derivation. I hope everybody went through that derivation with me. But then I gave you guys a shortcut. All you have to do is to find out the angle which is made by the free surface. All you have to do is go on that point, any of the point on the surface or inside the liquid only, and draw vectors of acceleration. So this is going to be g, and because our observer is going to be inside the fluid, so this is going to be the direction of pseudo acceleration, right? So the resultant of this, when you try to find that value, so this is going to be g effective, and the direction of g effective will always be perpendicular to the free surface. Okay, so I might take some time to get accustomed with the office setup here. I usually take sessions on my laptop, but today this is a big screen in front of me, so that's why things are a little weird, things are a little awkward in terms of the magnitude of the things in front of me. Okay guys, so if we talk about this angle, so we can get into the diagram once again. We can say that this angle is going to be theta, so the next angle is 90 minus theta. So this again becomes theta. So from here you can see that g effective, first of all, g effective is going to be under root of a square plus g square, right? And the value of tan theta is going to be a by g. So this is what tells us the angle theta which is made by the free surface with the horizontal when it is accelerated with an acceleration a. Okay, next. Then we spoke about manometer, YouTube manometer, and realized that inside this manometer, if I fill mercury, and one of the ends of the mercury is exposed to the atmosphere, the other one has some gas whose pressure is something that we want to find out. So the property that we always use is that any 2 points in a given liquid at the same layer, they're always going to have the same pressure. So we can say that the pressure at one point is going to be equal to the pressure at point 2. So P1 is nothing but gas pressure, the pressure which is created by the gas here. Okay, P gas. While here, definitely there is atmospheric pressure acting at P2, there is atmospheric pressure, and there is H rho g column of the mercury, which has to change its height so that it can create the same amount of pressure. And from here, you can easily make out that gas pressure is more than the atmospheric pressure. That's why the mercury column on the right side of the U tube is rising a little bit up. Okay, so that's what is the value of the pressure, which we found last time. Okay, everyone is comfortable with this, I guess. Okay, so everyone, let's solve a quick quiz question based upon what we did last time. And the question in front of you should be an easy one for all of us. Question says that we have to find the pressure P exerted by liquid on container walls when H is the height of the liquid column. Instead of rho, they are giving us F as the density of the liquid and G as usually the acceleration to gravity. So which of these do you think is going to be the expression of the pressure? So free marks. I'm hoping that everyone will be able to answer this. Giving you guys 45 seconds for this. Okay, guys. So the time starts in 3, 2, and 1. Okay. Hold on a second, you guys keep solving. Okay, so this is a very easy question for all of us to do. Okay, I was expecting actually everyone to be able to answer this, because this question can actually be done without even knowing the formula, just by looking at the dimensions also. But maybe 45 seconds are not enough to check the dimensions. But otherwise also, we know that the pressure formula, we did a very good derivation in the first session of this chapter. It is H rho G. So instead of rho, you will simply say it is H into F into G, and in the long run you can always check the dimensions as well. Okay, guys. So correct answer comes out to be option A. Okay, guys, am I clearly audible, loud and clear? Am I audible properly, everyone? Okay. If I'm not audible, then why people are able to answer no? That's a trick question, obviously. People who are not able to hear me should not be able to respond to the hotspot. Quickly respond to the hotspot if I'm audible to all of you. Okay, thank you for the response, everyone. So hoping that everyone is able to hear me. I'm trying my best because I cannot keep this right in front of me, because then I'll not be able to see the screen only. Okay, guys. So let's start today's session. Today we have only 2 topics to cover, and they're actually very small topics. The first one is what happens if the container in which your fluid is placed, that container starts to rotate. If that container starts to rotate, what happens? The second one is basically something that many people were asking in first 2 sessions. That's what exactly Pascal's law. Can you tell us about it? So we'll be speaking about Pascal's law today, and not just that, we'll be speaking about its application. So first thing first, we'll speak about what happens when you have a container, and in that container, say some fluid is filled, liquid is filled, and that container starts to rotate. Okay. So let me ask you guys, if we speak about, say, the washing machine in our houses, the washing machine, whenever it tries to wash the clothes, water is obviously filled. So when it is rotating, does the water level remain horizontal? Does the water level remain horizontal? The free surface? It does not. What kind of shape do you think the topmost surface creates? Is there another conical, or not exactly conical? Is there a bowl kind of shape which gets created? Right, a funnel or a bowl, right? Katuri kind of shape gets created over there. Why does that happen? We'll be speaking about that today. Okay, I'll give you a brief introduction of that also. Say if this is your container in which you have water or any fluid which is filled, right? So when you are filling the fluid inside and not moving the container in any which way, things remain very stable. But maybe if you start rotating your container, we just now spoke about what happens when there's additional acceleration that is involved. So guys, say in this case, can I say that definitely mg or gravity is definitely acting downward? Still it is happening, right? Gravity is still acting. But from this point, can I say that for any point, definitely there will be centrifugal force which will be experienced? So at any direction, if I look at, then there will be away from the center direction omega square r, or v square by r. What do we call this acceleration? Will you call it centripetal or centrifugal? Centripetal or centrifugal? It will be centrifugal force trying to create the centrifugal acceleration. So just once again for you people to visit this, remember this diagram we saw. So the net acceleration or G effective when we speak about, is this going to be the direction of G effective, right? So what is going to happen, guys? Your liquid surface, okay? What is going to happen to the liquid surface? That when we look at any of the sides of the container, say this is where G is acting, okay? And this is where omega square r is acting, and we found out the resultant as well. So this comes out to be G effective. So at this point, the free surface has to be perpendicular to it, right, everyone? So what happens to the entire surface? It takes a shape of a bowl, kind of a bowl shape. So at different points when we try to look at this, because r will be different. At different points, can I say that the value of r will be different? Do you agree? G is definitely constant, but r is definitely different. So omega square r as keeps on increasing, this G effective also starts bending towards omega square r. That's the interesting part of it. That vector G effective, it starts bending more towards omega square r. Because of that, the shape also starts becoming more and more steeper. Okay, getting the whole thought? So that's why it doesn't become a vertical or rather a line kind of shape. It doesn't become a planar shape like this. Rather, the fluid has a shape which looks more like this. Getting, everyone? So if we consider a cylindrical vessel, switching off the chart so that we focus now, consider a cylindrical surface or cylindrical vessel rotating at a constant angular velocity omega. So earlier maybe the omega was 0, and if we say that it contains some fluid, and initially maybe it was not out of shape, but as it starts to rotate, this is the kind of shape which we start expecting to be formed there. Sorry, today my hand is not getting accustomed to this new vacuum. Because of that, I'm finding it a little challenging to write and draw. Okay, so bowl kind of shape gets formed. Now what is our objective? What is our objective is we basically want to find out at a certain distance x or at a certain radius x, how much height the liquid has actually gone up. Okay, that means what? If I talk about this point is P, the radius of this point is x. So you can see that there is some height to which the liquid has come up. So our objective is to find out an expression, a general expression of y in terms of x. So if entire x becomes r, then what is the total height by which the liquid has risen up? That basically we want to find out. So as the liquid is now changing a shape and becoming a bowl kind of shape, so at a given distance from the axis of rotation, if I go, how much liquid has risen at that point from the normal earlier surface? Okay, guys. So if you look at this diagram, say at any random point P, I say that the radius of this point P, because it is also going to move in a circular path, right, of its own. So I call that distance to be r, radius to be x, and the height by which your liquid has risen up is y. And this is making an angle theta with the horizontal, so you can write this also as a theta angle, right, everyone? So I showed you this, that if G is going to be in this direction, omega square x is going to be in this direction, this is going to be the direction of G effective. Okay, now this point P definitely has to maintain its position. So if you talk about the components of omega square x and G along the tangential direction, the G effective has to be a direction that is perpendicular to the free surface, right, everyone? This is basically the direction of the free surface. So the direction which is tangential has 2 components of acceleration. One you can see is omega square x cos theta, the other one is G sin theta. So can we say that if point P has only net force acting along the direction of G effective, then these 2, the tangential components, should cancel out each other? Can I say that, everyone? Are you able to grasp that point? Logic everyone is getting this point, right? So we can say that, look at this point, this line at P, we can say that omega square x cos theta should be equal to G sin theta over here, everyone. So we can write sin theta by cos theta is going to become omega square x by y. Okay, and because the value of this tan theta will keep on changing as it is not a straight line. You can see that from point A to point B, the line is not, it's basically not a straight line, it's basically a curve. right everyone? A to B is a curve. So that's why the theta angle is also not constant. It is drawn for a given point P, right? So we can say that this is basically representing a slope for a small portion. Point P is a very small portion of the layer or the surface. So dy by dx is what we call it as the slope also. So dy by dx is omega square x by g. My objective is to find out y. So I can say dy is going to be omega square x dx by g. What is constant? The velocity with which you are rotating it. What is constant? G, the acceleration due to gravity. So they come out of the integration, and you can say that this will go from 0 to y, and this will go from some 0 to x value. Okay, so omega square and g comes out, and you will only integrate x dx. I hope everyone remembers the integration. X to the power 1 integration is going to be x square by 2, right everyone? So omega square by g is there, and the integration of x comes out to be x square by 2. So overall, a very important expression, I would say, everyone. You can actually solve many questions directly based upon this. That if I am at a distance x from the axis of rotation, to what height the liquid has gone up? Okay, you can actually now put at x equal to r. What will be the value of y? Y, which will become h, and that's going to be omega square r square by 2g if need be. And at x equal to 0, definitely the height also has to be 0, because there the effect of centrifugal force will be 0 at the axis of rotation. Okay. Nihal, you can write this in terms of v square by rg also, but you should know that during rotation motion, different points have different linear velocity. They all have the same angular velocity during rotation. It's omega which is same for all the points. Okay. Sir, vessel covered or not, will it make any change? In terms of pressure, it will, but in terms of the rotation, it will not. Due to pressure, the atmospheric pressure, the liquid level might go a little down also. This Y is for point P, any general point. We have found the expression for a general point. For any general point, we can talk about. If we know the value of y, we can find x. If we know the value of x, we can find y. Just remember, x is basically the radius, or you can say the distance from the axis of rotation. Okay. Yes. Okay. Yes, Arshan, we are not getting into circular motion today. We have already spoken about that very much in detail. Okay. We are using the concept of that. Now, another one. Say you have a tube. Okay. Imagine a test tube, in fact. You all have seen a test tube in the chemistry lab. Chemistry lab must have shown you the test tubes which are usually placed vertically. And say some fluid is filled inside the test tube. There is some fluid which is filled inside the test tube. Okay. And what we start doing, we start rotating the tubes. Okay. The test tube we start rotating, and by rotating, we eventually bring it horizontal. Let me ask you, will the liquid spill out or spill over when the tube has become horizontal and it is still rotating? If you stop rotating, definitely the liquid is going to spill. It's going to come out of the tube. But as long as you are rotating, it is not going to be. It's not going to come out. Now, by the way, you know the answer also, everyone. You know the answer as well, everybody. Yes, it's definitely the centrifugal force because of which the liquid is not going to come out. This liquid, say if I consider any column here, this column, say has mass m, it's going to experience m omega square r. What is r? R is basically the average radius of this point. Make sense, everyone? Does this make sense to all of you? Cool, awesome. Let's see how it works mathematically. Yes, r is the distance from axis of rotation, definitely, but the average radius basically. So now pay attention to this part. Say we are considering this column of the liquid which is rotating along with the tube. The left end A is at a distance x1 and the right end B is at a distance x2. R is the average radius. So if the distance of end A and B is x1 and x2, we will say that the average radius of this liquid column is going to be x1 plus x2 by 2, which you can also say is the location of the center of mass, by the way. The mass can be written as density into volume. I can write volume as area into the length of this column. What is going to be the length of this column? Guys, length of the column is going to be x2 minus x1. Okay, everyone? So if we speak about the pressure which is exerted on it, definitely the centrifugal force which is acting on it is going to make sure that this liquid column does not, spill to the left hand side. So definitely there is more liquid which is filled here, but we are considering a column of liquid here. This is the column of the liquid. The tube might be filled completely, but our focus is only between point A and B, right, everyone? Does this make sense? The liquid is not only between A and B. The liquid is maybe filled in the entire tube. We are only considering some portion of that liquid, which is lying between length x1 and x2, right? So that is why the mass comes out to be this rho into volume, and you see that volume is written as area into the length of the column. Length of the column is x2 minus x1. Okay, everyone? So how will I write the value of the force due to the liquid pressure? The liquid which is filled on the left hand side is creating a pressure that is P2 or rather P1, and the liquid which is filled on the right hand side is creating a pressure that is P2. So everyone, we know that the direction of the centrifugal force m omega square r is on the right hand side. Do you agree? M omega square is definitely on the right hand side as per the diagram. Yes. Can I say that the liquid column will remain at rest if the force due to liquid pressure is acting on the left hand side and these two are equating each other? Then only the liquid column will remain at rest. Getting my point, everyone? So that's why the force on the left hand side is P1A, the force on the right hand side is P2A, and P2 is greater than P1 for the obvious reason, so that the effective pressure is creating a force which is on the left hand side. The effective force on the body of this liquid column has to be on the left hand side, which can balance m omega square r. Okay, so P2A minus P1A is the net force due to liquid column pressure, and m omega square r average is going to be the centrifugal force on that. So that's why now the next term has to be listened to be very carefully. Mass, we are writing from here, rho into A into x2 minus x1. You see, this is written, which is mass. Okay, omega square into r. This r is x2 minus x1 divided by 2. Okay, so don't think that this x2 plus x1 by only x1 is not divided by 2. That's what I don't want you people to get confused with. Okay, so this is x2 plus x1 divided by 2. That's basically your r average. Now you see that a and a gets cancelled. So here on the left hand side I have P2 minus P1. On right hand side it is 1 by 2 into rho into omega square and a minus b into a plus b. So that's why it becomes rho omega square x2 square minus x1 square by 2. Are you guys all able to understand this? Give me a quick feedback in the chat box. Getting it? Do I need to remember? I think we can always derive this part. If you think that it is difficult for you to derive, then you can keep it in mind. Okay, but understanding the derivation is definitely important. Okay, formula for m, is it you did not understand how it came? Inward force is the force due to liquid column, the liquid column pressure. Okay, so this liquid column has to remain at rest. This liquid column has to remain at rest with respect to the tube. Inside the tube, this liquid column will remain there. That's what we are trying to say. Okay, Aradhya, how do we write the volume of a cylinder? How do we write the volume of a cylinder? Do we write the volume as pi r square h? Can I say pi r square is nothing but area? So area into height is basically the volume, right? So let me not write area as pi r square, just write it as a. And this height, if this distance is x1 and this distance is x2, what is this gap? Is it not going to be x2 minus x1? Harshita, wait a minute. Can I say it as x2 minus x1, the height? Aradhya, are you there? Just a second. Make sense? My voice is soothing. Oh, that's good. I thought my voice is irritating today. I'm actually trying to increase the brightness of the screen. Just a second, guys. Hold on a second. Yeah, much better. Okay. Vedantu does not give me this mic here at home. Okay, everyone. So listen to me. Listen to me now, everyone. If you look at this entire thing, यार एक तो इतना ज़्यादा अच्छा है मैंने number of slides कम ही रखे हैं. I have my laptop also with me. Okay, so think of this as a body, everyone. And this body has one force, m omega square, acting on it. Everyone. M omega square is acting on the right hand side. So can I say that this body will remain at rest when another force F is acting on the left hand side? Then only the body will remain at rest. Correct? So if the force effectively, this force is due to liquid pressure. Okay? This is due to liquid pressure. So can I say that on this side, the pressure which is acting, say that pressure is P2. And on this side, the pressure is going to be P1. Pressure will always try to compress the liquid, right? So just multiply this by the area. So now you tell me, if the effective direction of this force has to be left hand side, can I say that P1 has to be less than P2? Does it make sense to everyone now? That is why the pressure P2 has to be greater than P1. So that effectively, this force that we are drawing, the direction also is visible, is on the left hand side. Right, everyone? Okay. Cool. So we understood this? Yes, Arshad. Just a second, Arshad. अरे यार यहाँ पे आवाज नहीं है अर्शद यस अर्शद टेल मी अभी वही तो एक्सप्लेन किया अभी वही तो एक्सप्लेन किया एक बॉडी को अगर रेस्ट पे रहना है तो उसको लगने वाला नेट फोर्स 0 होना चाहिए तो ये फोर्स आर किसकी वजह से रहा है लिक्विड प्रेशर की वजह से ओके तो इस पे लेफ्ट हैंड साइड पे लगने वाला फोर्स जो है वो है P2 है उस पे राइट हैंड साइड पे लगने वाला फोर्स जो है वो है P1 है इन दोनों के अलावा ओमेगा स्क्वायर आर तो लग ही रहा है बाय द वे बट वी आर ओनली ट्राइंग टू टॉक अबाउट दिस एफ ओके तो ऐसा मत समझना कि ये P1A जो है वो ओमेगा स्क्वायर आर है नहीं दैट इज बेसिकली सेंट्रीफ्यूगल फोर्स व्हिच इज बिकॉज़ ऑफ द रोटेशन ठीक है या गुड ओके इज दैट क्लियर टू एवरीवन नाउ मेक सेंस ओके ग्रेट cool सबने नोट किया हुआ है एवरीवन हैज नोटेड डाउन दिस एक्सप्रेशन द हाइट बाय व्हिच द लिक्विड वाज राइजिंग एट एनी गिवन डिस्टेंस x cool because now the questions are coming for all of you अच्छा मैथ्स में कोनिक सेक्शन हो गया हैव यू स्टडीड और स्टार्टेड स्टडीइंग कोनिक सेक्शन okay then this one will go on chance the next question that is coming is going to go on chance okay everyone so question comes on the screen let's see how many of you guys will be able to identify this so water is filled in a container which rotates with angular velocity omega as shown so you have to talk about what is this shape which is getting formed I was using only a typical word I was calling it a bowl like a bowl this is how liquid whirlpool is created right so now we have to define it technically what this shape is called you have to comment on the shape okay giving you guys 30 seconds some of the options can be easily ruled out by the way and the time starts in 3 2 and 1 today I'm relaxed I'm not relaxed actually it's very odd to take the session after a very long time in the setup I'm not used to of taking sessions apart from my laptop okay everyone so last 5 seconds let's see how many of you guys are able to guess this properly because this is definitely something that you guys don't know mathematically so that's why it will be very difficult the answer lies in that expression only the formula that we derived a few slides back wow surprising many of you got the answer that's good nice so everyone when we write the equation which was y equal to what was the formula it was omega square x square by 2g okay so omega square x square by 2g it simply says that y is proportional to x square and we know that y proportional to x square is not a linear equation it is not even a circular equation okay so the actual debate will be between parabola and elliptical shapes so we know at least the shape of parabola I'm sure many of you have answered it without knowing the mathematical equation without knowing this relation you have actually looked at the diagram and answered it but let me tell you whenever y is proportional to x square this is a standard equation for a parabola we may require it in physics before you study it in mathematics so please remember this is y equal to y proportional to x square whenever that equation comes we call this equation to be parabolic equation okay in fact if you guys remember y equal to x tan theta minus g by 2u square cos square theta into x square where have you seen this equation before equation of trajectory remember parabolic equation parabolic path this is because y was proportional to minus x square so this is y equal to x square this is y equal to minus x square inverted parabola okay yes good so that's why the answer is parabolic shape more questions coming up switching off the chat so that you guys focus on the screen everyone so question this is a JEE Main 2020 question I hope you guys have noted down the formula because that will be required here to be applied it says that a cylindrical vessel containing a liquid is rotated about its axis so that the liquid rises at its sides as shown in the figure the radius of the vessel is given 5 centimeter and the angular velocity of rotation is omega so what do you think is the difference in the height of the liquid at the center of the vessel to the sides that means when x is equal to r what is the value of h is what the question is asking you to find out acceleration due to gravity is can be taken as g centimeter square per second you can take acceleration due to gravity as g centimeter square per second so giving you guys 60 seconds to figure it out and the time starts in 3 2 and 1 should be an easy one for all of you and if you know that expression you don't need to derive it you can easily find that out Come on, everyone. Okay. Wow, that's nice. That's nice. Great, guys. Great. You guys are informed today. Good, everyone. So it's directly an application of the same formula. Okay. So correct answer is going to be option C. Let's see how it comes out to be. Same formula, you see y equal to omega square x square by 2g. We don't need to derive it again and again. You can keep it in mind. If you ever forget, then you have to remember that the shape, the free surface, will always be perpendicular to the direction of acceleration due to gravity, is the effective value. So we again can find it out, but it's going to definitely be a time-consuming process, and it's a very standard, standard slide or rather standard topic that you're discussing here. So that's why keeping this expression in mind could be helpful. Okay. So y equal to omega square x square by 2g. Omega has been not given in the form of numerical value, and we have not been given any other value of, as an omega is not given, but x is going to become the radius, because you're talking about from this end A to the other point, means this is B and this is C. So the horizontal gap between A and C is R, while the vertical gap between A and B, or you can say B and C, is H. So y becomes H in terms of omega, and because the value of G is given in terms of centimeters per second square, so you don't need to actually convert this into meters. That's the biggest mistake that many students made that year in this question. Many of them thought of making this in terms of centimeters to meter. So omega square into 5 square by 2g. So this comes out to be 25 omega square by 2g. Okay. Though the options were not very confusing, but many of them got confused because of, first of all, not being able to recapitulate the expression. Okay. Just a second, please. So one more question based upon the same. This one is from JEE Main 2019. So this actually is indicator also that this is something which should not be taken lightly, this particular topic, because it has come very recently in JEE examinations. So the question now in front of you says that a long cylindrical vessel is half filled with the liquid. When the vessel is rotated about its own vertical axis, the liquid rises up near the wall. If the radius is again 5 centimeter and it is rotated with angular velocity 2 rotations per second, then the difference in the height between the center and the sides is going to be. So maybe the liquid is below also, but we don't care about that liquid part. We only care about this point A and this point B. If the horizontal gap between them becomes R, okay, if the horizontal gap between them becomes R, then what do you think will be the vertical gap between these 2 points? Okay, once again, the same expression, apply it, giving you guys 90 seconds, and the time starts in 3, 2, and 1. Try to be accurate, everyone. Last 30 seconds, everyone. Okay, and the time is up. So everyone, once again, the answer is 2, and here the possible thing which might have given you guys trouble is omega. If you use it directly as 2, then the answer will definitely not be right. It is 2 rotations per second. So you have to convert it into radians per second. So 2 into 2 pi, because every rotation has 2 pi radians. So omega is 4 pi radians per second, and R value will be 5 into 10 to the power minus 2 meters. Okay, but finally you will convert the answer into centimeters only. So again, the same, omega square x square by 2g. Omega is 4 pi, square that value. X is 5 into 10 to the power minus 2, square that value, and 20. When you simplify this, it will come out to be 2 into 10 to the power minus 2, or simply 2 centimeters. Okay. Great, awesome, guys. So this is what usually is the typical type of questions every time whenever the question comes. This is what the formula that directly gets applied, and I will still remember, rather I will still recommend, and if I'm at your place, I will remember how this expression is derived. Okay, remember, very important point, again repeating this point, guys. What we learned in the previous class, that the free surface of the liquid will always be perpendicular to the direction of G effective. And the interesting part about this is that G effective is not a constant. As the omega square x, it is dependent on x. As you keep on moving right side from this or any side from the axis of rotation, if you start going away from the center of the container to the sides of the container, you are increasing x. As x is increasing, right? As you move from the center towards the radial outward direction, x is increasing, so omega square x increases. So in that G effective, the G effective vector will also be not a constant. So that's why the shape of the free surface is not a planar shape, it's rather a parabolic shape. Okay, and the expression in front of you. Okay, guys, now moving on to the second topic of the day, and that is Pascal's law. Okay, I'm sure that you guys have heard about the Pascal's law earlier as well. What is Pascal's law? Say it has multiple application, and that's why it has multiple statements also. It tries to tell us, first of all, that maybe there is a container in which some fluid is filled. Okay, so maybe say if I speak about the container in 2 different situations. Okay, so in the first one, say if I speak about a case when the container is completely closed. Okay, and in the other situation, okay, the same container is open to atmosphere. That means what? Maybe in case 1 it was covered, and in the second case you have removed the cover over it. So if I speak about, say, 2 points and 2 different depths, so maybe this one is at a depth h1 and this one is at a depth h2, and let's call these points A and B. So I'll say that pressure at A is going to be h1 rho g, pressure at B is going to be h2 rho g. Fine. So now if you open this entire container to the atmosphere, and now you try to speak about the pressure at A and B, which are still at the same depth h1 and h2. Okay, so PA, which was h1 rho g, and by the way, there is atmospheric pressure acting now. Okay, let's call it P18. So earlier the pressures were these. Now, guys, will it remain the same pressure? PA and PA dash, PB and PB dash, will they remain the same? Is there any term that I need to add on this side, on the right hand side, in the second one? This is case number 1. This is case number 2. What is that term that I need to add? Do I need to add P18 only with PA? Do I do that, or I do that in both the expressions? PA dash and PB dash both will have the same value added. So are you trying to tell me that whatever was their pressure earlier, now if you are introducing another pressure, if you're introducing another pressure, it is getting distributed equally. It is affecting all the points equally. Do you agree on that? Okay. In fact, everybody, if you will keep this container closed and if you will put another mass on the top here, say if I place another mass here, so what will happen? If the area of cross section of this thing is S, you will have another pressure added in both the cases, mg by S. S is the surface area. It will affect both of them equally. So this is what is Pascal's law. What does it say? That if you try to change the pressure at any surface or at any point in the container, in the liquid, it's not going to affect only that point. It's going to affect all the points on the liquid equally. That is what is Pascal's law. Okay. Yes, you have definitely studied this in chemistry, maybe in earlier classes also. So let's have a look at the formal definition. Also, it says that change in pressure at any point in a confined incompressible fluid. Yes, I hope I need to. I have already spoken about it in the beginning of this unit. I'm restating this right now. There were two classifications which I did. First classification was real and ideal fluids. So we are studying ideal fluids, which are incompressible, which are not going to show viscosity, okay, which will not show something called as surface tension. And we are right now studying fluid static. We are talking about ideal fluid and also they are at rest. So ideal fluid will be moving in a few sessions. We'll be speaking about the motion of the ideal fluid. Then we'll speak about the real fluid when we'll start speaking about that there is a viscosity. There is difference in the movement of different fluids. The way water moves, honey does not move with the same speed. Oil does not move with the same speed. So there is some stickiness in the fluid, which is also because of the real nature of the fluid. So right now we are considering there's only one fluid and it has no viscosity. So coming to this, a change in the pressure at any point in a confined incompressible fluid at rest is transmitted undiminished, or more simpler word to say is uniformly, it is transmitted to all the points in the fluid. If you understood this, you will be able to understand every single word which is written here. Are you guys able to understand that it is actually stating the same thing in a technical manner now? That if you try to change the pressure at any point, it's going to affect all the points in the fluid. It doesn't matter whether that point is above or below. It's going to be distributed equally in all the possible directions. That's why I say when we try to blow air in a balloon, the balloon does not just expand in the direction where you are blowing the air. It tries to expand it in all possible directions. Okay. Also, it says one more thing, guys, that the pressure exerted at a point is same in all directions, though we have spoken about it earlier also. Means what? The pressure created at a point is created equally by all the surrounding points. We have spoken about this earlier as well. Okay. So let's prove this also. Let's prove this as well. Say if I consider a point P, okay, a very small, this prism kind of shape that you see, it's the imaginary liquid prism. Okay. And it is actually a very small prism which is surrounding point P. And we want to say that we want to prove that if you apply force in any possible direction on the liquid at that point, it's going to create the same result. So say guys, you are creating one slanted surface so that the force which you are applying is FB, and this FB has two components. Okay, this FB has two components. That component is FB cos theta and FB sin theta. Okay, that means this angle is theta. Similarly, there is horizontal force which is FC, and there is vertical force which is FA. If this triangular imaginary prism has to remain at rest because liquid is at rest, can I say that everyone? The horizontal force FC should be balanced by FB sin theta. Do you agree? Should be balanced by this. Similarly, the vertical force FB cos theta should be balanced by FA. Then only the imaginary prism that we are considering will be at rest. Okay. Okay, so we can say that FC has to be FB sin theta in horizontal direction and FA should be equal to FB cos theta in the vertical direction. No problems there. So can I say that similarly this triangular prism, if we start talking about the components of the area, can we also say that FB cos theta is, AB cos theta is equal to AA? Do we understand this part? The horizontal component of area and the vertical component of the area. So AC is AB sin theta, AA is AB cos theta. Okay, everyone? Because we wanted a slanted surface also. Priyanshu. This will be valid for any imaginary surface, by the way. Yes. So can I say that if I try to find out the value of the pressure on all the surfaces, the pressure on surface number 1 is created by FC? Everyone, can I say that pressure on surface 1 is created by FC on area AC? So how will I write the pressure? FC divided by AC, right? Similarly, pressure on surface 2 is because of FB, so that is FB by AB. And similarly on this surface, that is surface 3, it is FA by AA. So FA by AA. Okay, so you can divide these two together. Okay, so when you divide these two, take these two, you will get the same expression by dividing it here. Okay. My breathing is also audible today. Huh, everyone? Is my breathing also audible today? Oh my god, maybe this is very close to me then. Though there is a filter here. Okay. Sir, Pascal's law is only about theory. No, Aradhya, we'll see. We'll see. The Pascal's law has mathematical application. So everyone, we are just proving the same point once again, that pressure at a given point is same in all possible directions. Okay, everyone's clear with this? Chalo, let me see if you guys remember something that we studied or I taught you last time. Okay. I'm breathing too much, so should I stop breathing? Chalo, answer this one quickly. Find out the relation of pressure among point A, B, and C. Let me see how many of you remember this from the session number 1 itself. What will you comment about A, B, and C when the height to which the liquid is filled in all the three shapes is same? Giving you guys 30 seconds and the time starts in 3, 2, and 1. Let me breathe. I was holding my breath. Okay, last 5. And the time is up. Time is up. Thank you for not responding otherwise in this, though some of you did, but I'm still happy that majority people remember this very simple point that I taught you guys in the session number 1 only, that the shape of the container does not affect the pressure. Whatever be the shape of the container, as long as, yes, hydrostatic paradox, exactly. So as long as the shape, or rather as long as the height is same, yeah, even if the weight differs, the pressure at the same depth will remain the same. Obviously the same liquid. Okay, so answer comes out to be option D here. Okay, Arshad, okay. Exactly how many bottles do I have? So 2 bottles are already there from the office. And the one that I have my own, obviously. I'm carrying my prop, my metal bottle, the steel bottle is there. This one. The physics bottle, demonstration bottle. Okay, so let's speak about the application of Pascal's law. The application is a beautiful one actually. Pascal's law has a very beautiful application which we call as the hydraulics. Have you guys ever been to a workshop where they do the maintenance of vehicles, 2-wheelers or 4-wheelers? Have you been to that workshop? The service centers? So you must have seen that they lift the vehicle. they lift the vehicle up. Okay, so I don't know, with four-wheelers nowadays the technology is so advanced that they don't need to do it manually. But I still remember taking my own two-wheeler, and don't ask me which two-wheeler do I have. I do not have any Bullet, I do not have any fancy two-wheeler. So when I took my two-wheeler for the first time to this workshop, this guy, he puts it on that lift and he himself is pushing it by his legs, the hydraulic port. And when he's pushing, the vehicle is going up. Yes. So this is how Pascal's law gets applied, and how it gets applied is what we are going to do. So how does it work, guys? This is such a beautiful application. Okay. Yes, I have Jupyter. Bas, तुम लोगों को मौका मिलना चाहिए. So everyone pay attention to this slide. This is a very important and interesting one. This is application of Pascal's law on hydraulic forces. So see that this fluid is filled inside and it is incompressible. Okay, and it has to be at rest. So inside this, I have this diagram that you see. I have chosen a shape where the areas of the pistons, these are called pistons. Pistons are basically the covers. So these pistons are of different areas of cross section. Okay, so what you see here, that area over here is A2 and area over here is A1, and visibly A1 is greater than A2. So everyone, can I say that in order to keep the fluid inside stationary, if I start applying a force from this side, there will definitely be a pressure which gets created. And to keep the entire fluid stationary, I also apply another force on the other side of the liquid, that is on this piston, that is piston B. To keep the fluid stationary as well as incompressible, can I say that the pressure created at the point 1 or at piston 1 or at piston 2, can I say that the pressure must remain the same so that the fluid remains incompressible? Also, the fluid remains at rest. Right, everyone? Yes. So this is the beauty of the Pascal's law, that because the pressure throughout is going to remain the same at any given layer. If I consider this layer, layer 1, or another point on the same layer 2, we know that the points which are belonging to the same layer will always have the same pressure. So P1 should be equal to P2. And the beauty is, on the left hand side, when I try to write the pressure on the bigger piston, the one which has bigger area, that comes out to be F1 by A1. On the other side, when we speak about the smaller piston, the pressure comes out to be F2 by A2. But guys, the smaller be the area of the piston, the smaller is the force that I require. The smaller is the force that I require to still maintain the fluid at rest. Yes, absolutely yes. And now look at what happens in case of a workshop. So this is where they keep a very small area of piston, while on the other side, where the vehicle has to be lifted, they keep obviously a bigger area of the piston. But if I speak about any given layer here, can I say that the fluid is going to have the same pressure delivered? Right? So when we talk about the pressure being same, we can say that F1 by A1 should be equal to F2 by A2. Right, everyone? So even when maybe somebody standing here, a person whose mass is say 80 kg, he will still be able to balance your vehicle, which is of the order of 1000 kgs. Only and only because of Pascal's law. You will be able to balance out a vehicle practically. Yes, you can. Okay, but yes, in the real world, that fluid definitely is not ideal. So there are special hydraulic fluids which are very, very, very less compressible. Their compressibility is very less. The work modulus is very high. Okay, I have not tried it. I have used smaller hydraulics definitely. Not mercury. Mercury is a very expensive fluid. There are hydraulic oils which are placed. Guys, is the logic clear that you will be able to deliver a larger force by just having a larger area of cross section, because the pressure is going to remain the same on the two sides of the hydraulic arrangement. So left side, the cylinder that you see has smaller area of cross section. On the right hand side, expensive fluid. There are hydraulic oils which are placed. Guys, is the logic clear that you will be able to deliver a larger force by just having a larger area of cross section, because the pressure is going to remain the same on the two sides of the hydraulic arrangement. So left side, the cylinder that you see has smaller area of cross section. On the right hand side, it has a bigger area of cross section. Okay, so now just questions to be solved, guys. Let's have a look at an example, then you guys will do the solving. Yes, many people actually do this science experiment with the help of syringes also. Yes, I have seen that experiments being done by many students. You can try that. Okay, that's the formula that you saw, by the way. So switching off the chat. So in a hydraulic system, a piston has an area of 21 centimeters square, which pushes on a liquid with a force of 38 newtons only. On the far end of the hydraulic pipe, it connects a second piston whose area is obviously much bigger, so definitely more force will be delivered there. So what is the force on the second piston that we want to find out? Logic is very simple. F2 by A2 should be equal to F1 by A1. So we can say that F2 is going to be equal to F1, that is 38 newtons, into the bigger area, obviously bigger be the area, bigger be the force, 100 centimeters square divided by 21. So we will simplify this, do the maths, we'll get the answer also. Okay, so that value, when you calculate the pressure, you can calculate the pressure also, you don't need to, you can directly just simplify this part itself. So both the areas are in centimeters. So 3800 divided by 21. When you do the maths, that value will come out to be 1.81 into 10 to the power 4 Newton per meter square. That's the pressure. And when you calculate the force, that will come out to be 181 Newton. So you see, on one side there is only 38 Newton force applied, and on the other side you are able to deliver a force of 181 Newton. Okay, everyone? Make sense? Everyone is able to understand this simple application? Will you be able to solve the questions based on the same? Be ready to do the calculations though. Almost 6 times. Actually, not almost 6 times. It's roughly 4.5 times. Yeah, okay, Radha. So everyone, answer is option A. And moving on to quizzes, you will be solving 3 questions, and yes, surprising will be done after that. Okay, first question, all of you. It says that, very carefully you need to read this. A medium-sized car typically weighs 1000 kgs with the G value given as 9.8. A hydraulic system of jack to jack the car up, that means to lift the car up above and to inspect. Okay, it has been placed above an inspection pit which has 4 slave cylinders. By slave cylinders, we basically mean the pistons are basically 4. There are 4 pistons over there, or 4 cylinders over which pistons are placed, and they are collectively going to lift the car up. So they have each area of 0.1 meter square. The cross-section area of the master cylinder, that means where you can say the lower force will be applied, is 0.00125 meters square. So what do you think will be the minimum force that must be applied to the master cylinder to raise the car up? Obviously, we don't want to apply 98,000 kgs of force, because that is something which is very difficult for us to apply. So how much minimum force will be required, or how much force will be required to lift this car up? Only thing that you need to remember is that area of the slave pistons is 4 times 0.01 meter square. Okay, giving you 2 minutes, and the time starts in 3, 2, and 1. Come on, guys. Just have to equate the pressure on both the sides of the hydraulic system. Okay, so here the area is 4 times A2. Here it is given as A1. Here how much force should you apply is what is being asked. And here obviously you need to put the car whose mass is given. So remember, this 4 is very important here. Okay, and the time is up. Okay, little decent. Could have been better, everyone. So F1 is going to be F2 by A2 the pressure, multiply that by the area A1. The only thing that you needed to understand that where the car is placed, there are 4 cylinders, so area has to be 4 times. So if I speak about the weight of the car or the force, it is 1000 into 9.8. I would personally want to take it as 10 meters per second square, but the options are very close. Because the options are very close, that's why I did not recommend or I did not say that you take G value as 10. Okay. Now area is 0.00125, so I can say it is 1.25 into 10 to the power minus 3 divided by A2, which is 4 into 10 to the power minus 2. This is 10 to the power minus 2 only. Okay, so 10 to the power minus 3 cancels with 10 to the power 3. This is 9.8 divided by 4 into 5 by 4 into 100. So this is 5000 by 16. So when you do that value close to 3, this value actually comes out to be 3.06 into 10 to the power 2 or 306 newtons. This is the value that you get. Okay, everyone. Those who did not get this right, they realize the mistake. Everyone understands? Easy it is, calculation mistake. So that's why I'm giving you so much time so that you guys are able to solve this. Okay. Okay. What's the value of G that I need to take is dependent upon the options also. If the options would have been spaced up, say if this option was 350, this option was 400, this would be 306, and this will be 250. There is no way I will take the value of G as 9.8. Then in that case, I will definitely take the value of G as 10 because I know that there is a lot of spacing between the options. But right now you can see that the options are so close that I can actually create a lot of error by not taking the value of G as 9.8. That's why 308 and 306 are very close here. That's why. A2 कैसे लिया मतलब? मैंने बताया भी ना, यहाँ पे भी बताया था that there are 4 slave cylinders. मतलब यहाँ पे 4 cylinders are being placed. That is why cylinder 1, 2, 3, and 4 they together are lifting it up. That's why. Okay. That's Mustafa. You cannot take G value as 10, and that is why they have clearly mentioned G value 9.8 also. Okay. So next one, everyone. So in this one, in a simple hydraulic system, piston 1 has area of cross section given to you. Be careful with the number of zeros after decimal. And the piston 2 has area of cross section. Again, be careful with the number of zeros. If the force of 35 Newton is applied on piston 1, okay, this is the area of piston 1, by the way. So then, what is the force multiplying ratio? Okay, let me just check it. Is the ratio they're asking or they're asking for force? Because unit suggest that it is. Okay, there will be no units here. You have to talk about the ratio of the forces. Now, is it F1 by F2 or F2 by F1? I want to see how much is the presence of mind in my batch. I'm not telling you whether it is F1 by F2 or F2 by F1. I want you people to decide that. Giving you full again 2 minutes to think about this, and the time starts in 3, 2, and 1. Come on, everyone. Come on, everyone. Still more than 1 minute. Last 5 seconds now. Just a second, please. So how do we decide F1 by F2 or F2 by F1? How do I decide? What do I need to find? What's the logic? The logic. How did you rule out? What do I not need to find out? Yes, Kostov, very good. Yes. Guys, look at the options. Look at the options. Do you see that all the options are more than 1? Do you see that all the options are more than 1? That means we have to find out the force greater or force big versus force small. That means area which is big is to area which is small. That's it. Getting the logic, everyone? Which one is bigger area, A1 or A2? Which one is bigger area? we are simply applying the formula only. I'm not saying that we will go by some other formula. We'll apply the same formula. But do I need to solve a2 by a1 or a1 by a2? That's basically what I needed to decide. Yes, it is a2 by a1. a2 is bigger. Do you see that, all of you? This is 25 into 10 to the power minus 5 meters square. Everyone is able to count the number of zeros and the decimal places. There are 5 decimal places, right? Similarly, here also it is 5 into 10 to the power minus 5. If you write 50, then it is 10 to the power minus 6. Got it, all of you? So the value comes out to be 5. Yes, Arshan? There are two pistons. Where have we multiplied 2? Why? There is piston 1 and piston 2. One is this, another is this. This is where you are standing, and this is where a car is standing. So this is area A1, this is area A2. So the force that you apply is F1, the force that the car applies F2. But the pressure that you apply, F1 by A1, and the pressure that car applies, F2 by A2, they will remain the same. That's the logic by which this comes. Piston 2 and 2 piston, this means entirely different. Altogether different understanding. Okay? Okay. Chalo, everybody, extension of the same question and the last question for the day. Okay. So everybody, question on the screen. This time they're asking us to calculate the output force generated by piston 2. So in the previous question, now you want to find out what is the force applied on the bigger piston. Because on smaller piston, the force applied is given to us. Giving you people 90 seconds on this, and the time starts in 3, 2, and 1. Should be an easy one for all of you. Last 20 seconds, guys. Okay. And the time is up. So as this is an extension of the previous one, I think everyone would find it easier. So guys, we already know the value of F2 by F1 from the previous question came out to be 5. You can do that again though, but you don't need to. So F2 came out to be 5 times of F1. That is 5 times the value of the previously given force, that is 35 Newton, comes out to be 175 Newton. That's the answer. Okay. Cool. So as I said, yes, we have less number of slides today. So we have completed almost half an hour before. Let me show you the leaderboard as well, everyone. Congratulations to those who we did 8 questions. Wow, that's nice. Congratulations to all those who have made it to the leaderboard today. Well done. Very well. Ansh, Krishna, Jessica are the top 3. Then we have Aditya Rana, Shashank, Udit, Harsh, Shubhatman, Rani, Rajalakshmi, Akshat, Keith, Sanidhya, Keith I think, Sanidhya, then Dhanush, and then Tushar. Okay. Great job, guys. Let me mute the system. I don't know, maybe it makes some sound here. दे दिया ढोल यार, कभी मना किया ढोल देने को? ये भी लो. Okay. So good job, guys. Great job. So this brings us to the end of the session also. I'll be sitting on the chat, class teachers. Once you're done explaining your doubts, you can fix it. Okay. So everyone. Great. So we finished early today, so that I can have dinner also. Absolutely, yes, Prithvi. So you are not well? No, I'm absolutely well. Just a little tired, nothing else. Yes, Prithvi. Just a minute, don't speak. Yes, Prithvi. Slide number 25. 25 is this. Okay. What about this one? This one, right? Tell me. I lost you in between. Can you repeat? Again gone. Prithvi, can't hear you. Voice is breaking in between. Yeah, but again, the same problem. Sometimes I can hear you, sometimes I can't in between. That will also get added. Say you have added some P0 pressure more. This is what will happen. Yeah. Any pressure, any external pressure. In any of the cases you add. Okay? Yeah. Okay. Cool. Okay, leaderboard. Okay, leaderboard और देख लो. Yes, and those who want to leave can leave. Hi, cool. Tell me. Location of the center of mass will move. Yes, it will shift. तो फिर क्या करोगे? तो फिर ये एक्चुअली क्या होता है, हमने कोऑर्डिनेट ऑफ सेंटर ऑफ मास पता लगाने के लिए m1 x1 प्लस m2 x2 अपॉन m1 प्लस m2 ये पढ़ा था. तो मान लो ये ओरिजिन है. अब ये वाला जो पोर्शन है उसका m/2 मास होगा और ये वाले पोर्शन का मास m/2 होगा. तो m/2 अब लेंथ भी दोनों की l/2 और l/2 हो जाएगी। मान लेते हैं 2l लेते हैं अपनी लाइफ इजी बनाने के लिए, ठीक है। तो इसका कोऑर्डिनेट हो गया होगा l/2, 0 सेंटर ऑफ मास का, और इसका हो जाएगा 0, l/2। बस यहाँ पुट कर दो तो x कोऑर्डिनेट आएगा, सिमिलरली y कोऑर्डिनेट भी निकालोगे, m1 y1 m2 y2 और m1 m2, ऐसे। तो फिर उसके कोऑर्डिनेट निकालने पड़ेंगे। मान लो ऐसे रेडी कर दिया तो तुम्हें एंगल थीटा की जरूरत पड़ेगी, तो ये कोऑर्डिनेट निकालना पड़ेगा, कोई बात नहीं, हो जाएगा ना, 180 tan थीटा लगा देंगे या अदर ट्रिग्नोमेट्री लगा देंगे, y और x निकाल लेंगे, बस वी जस्ट नीड द कोऑर्डिनेट्स, नथिंग एल्स। m1 और m2 के कोऑर्डिनेट्स चाहिए, ओके। Nihal Tapsi, both the formulas are valid every time, but with rotation motion, omega is constant for the entire body. The formula v square by r is also valid, but you will have to apply it for every point in that case. So it is easier to apply as omega square r. Okay, Antriksha. Hello. Important in the sense, अगर वो expression भूल गए तो derive करना आना चाहिए। क्या प्रॉब्लम है? क्या यार, ये एंगल थीटा है तो ये कंपोनेंट g cos थीटा बनेगा, ये वाला g sin थीटा बनेगा। एनएलएफ सीखा क्या चीज? बेसिकली टेंजेंशियल सरफेस के टेंजेंशियल डायरेक्शन में देयर विल बी नो इफेक्टिव वैल्यू ऑफ एक्सेलरेशन, क्योंकि सरफेस अलाइन ही परपेंडिकुलर डायरेक्शन में होगी टू द नेट डायरेक्शन ऑफ जी इफेक्टिव। तो जी sin थीटा को ओमेगा स्क्वायर x cos थीटा को कैंसिल करना पड़ेगा। Got it? Anything else? तुम एनएलएम में मेरे साथ नहीं थे क्या क्लास में? लॉज ऑफ मोशन। तो कभी भी हम जब वेक्टर्स को रिजॉल्व करते हैं, दिस इज एक्चुअली नॉट इवन एनएलएम, दिस इज एक्चुअली वेक्टर्स। मैंने एक टेक बताई हुई है कि कभी भी अगर किसी वेक्टर को रिजॉल्व करते हैं तो मान लो ये वेक्टर थीटा एक्स एक्सिस के साथ बना रहे हैं, सो द साइड व्हिच इज मेकिंग द एंगल विल ऑलवेज बी द कॉस कंपोनेंट, साइड व्हिच इज नॉट मेकिंग द एंगल इज साइन कंपोनेंट ऑलवेज। ये पता है? ये अप्लाई किया, देखो यहाँ पे आते हैं, ये देखो जो साइड ओमेगा स्क्वायर एक्स के साथ एंगल बना रही है वो कॉस है, और जो नहीं बना रही है वो मैंने लिखा नहीं है, वो साइन होगा। जहां जी इफेक्टिव के डायरेक्शन में ओमेगा स्क्वायर एक्स साइन थीटा आएगा। सिमिलरली जी थीटा एंगल बना रहा है जी इफेक्टिव के डायरेक्शन में, तो वहां आएगा जी कॉस थीटा, लेकिन जहां नहीं बना रहा है वो कंपोनेंट क्या होगा? थीटा। ऐसा समझ में? ओके, ठीक है एवरीवन। यस मोनीश, आई विल अनम्यूट यू। हाय मोनीश, गुड इवनिंग बच्चा, बोलो। कम अगेन। दिस इज अ वेसल, ओके। हां, जस्ट अ मिनट, लाइक अ बकेट। कम अगेन। हां, राइट। हां, फोर्स और प्रेशर, force will be the amount of pressure exerted divided by the area of this thing. It is not on the base, and what you are trying to find out is not on the base, it is on the inclined surface. Basically what happens, if I speak about the inclined surface is also supporting the liquid, right? The inclined surface is applying a force say in this direction, so can I say that the inclined surface is going to experience a force like this? So because of that, what happens, if I say that this angle is theta, so because of that, if this is theta 90, so this also becomes theta, so this will be your f sine theta force which is acting vertically downward. Are you getting? It's not entire f which is acting vertically downward, it is f sine theta which is acting downward. So if I look at the free body diagram of the liquid, if I consider liquid like a body, then downward force is mg plus f sine theta, while the upward force from the bottom of the surface is the normal force, which is supporting the entire liquid to not fall down. So n, which was earlier supposed to be mg plus f, this f is because of the liquid pressure, has become f sine theta. Getting? If you consider a container like this, then the entire force due to liquid pressure acts vertically downward. So here the equation you write as n is equal to mg plus f, while here it has become f sine theta. So if I call this as n dash, we can simply clearly see that the same force, if the same pressure is exerted, then definitely I can see that n dash is less than n in that case, right? What is? There's only, okay. Pot as in what kind of shape is there? This kind of, this? Okay, okay, okay. So this is capital H. The liquid is filled to a height capital H, no? Near the curvature as in here. Here. As in, I'm not getting it. Here. And this is at a height small h, okay? Whatever. They're asking for pressure or force? Base pressure, na? So what is this depth going to be? Capital H minus H. It is open to atmosphere. Option has AP, ATM also. P naught. I think it is covered. It is covered. The gauge pressure is going to be H minus H into rho g. What is the correct answer as per the small h rho g? Is the diagram given in the question? And height h small h is mentioned from the bottom? Then answer is wrong. In that the answer is wrong. We always write this from the surface. We write h is basically not height, it is the depth. So, okay. So gauge pressure at this level is going to be H minus H into rho g. We have done the derivation. Okay. Okay. Can you read the question for me? That's it. Okay. Because I think either there is a standard mistake which is there in every time whenever this question has been solved. The height either should have been given from the top of the free surface, from the surface. Then the answer will be HROG. Otherwise, the answer cannot be HROG. Okay. Yeah. I'll also check. Right now, my laptop is not with me, and we do not have Tattva on the system here. Okay. Yeah. Okay, bacha. Bye. Yes, Nihal. The free surface of a liquid is always perpendicular to G effective. I explained this last time in the previous class. This one. Okay. We have done like this entire derivation there also. So if you have not attended that class, then just go through the class once. Okay. Okay. Bye. What? Oh yeah, hasta la vista. Bye bye. Okay, guys. चलो then everyone, I think सर प्रिज्म पर कौन सी फोर्स लग रही है? वो सारी फोर्सेस वो एक्चुअली प्रिज्म नहीं है। पहली बात तो हर्षिता, वो एक्चुअली कोई ग्लास का प्रिज्म नहीं है, वो इमेजिनरी प्रिज्म है। वो इमेजिनरी प्रिज्म है और उस पर जो फोर्स लग रहा है वो लिक्विड प्रेशर की वजह से ही लग रहा है। और लिक्विड हमेशा फोर्स परपेंडिकुलर टू द सरफेस ही लगाता है। तो ये सारी फोर्सेस लिक्विड प्रेशर की वजह से लगे, तो हमने प्रूव किया है कि वो सब सेम प्रेशर ही है एट अ गिवन पॉइंट। ओके, यस यस, टीचर्स आर देयर, दे आर टेकिंग सेशंस। ठीक है, चलो guys, I'll wrap up today early. We'll speak after I reach back Mumbai. We'll not be able to communicate much in the class, in the next class also. ठीक है everyone? Yes. गौतम नेक्स्ट टाइम बात करेंगे, ठीक है? फिलहाल कैरी ऑन फॉर दिस वीक, विल स्पीक वंस आई रीच बैक टू माय होम। ओके, थैंक यू। ओके गाइस, एवरीवन, लेट्स साइन ऑफ। आई विल सी यू ऑल नेक्स्ट टाइम। टिल देन, टेक केयर, बाय, गुड नाइट, हasta la vista, sayonara। यस।